Right, guys, practicals for tomorrow's paper. You need to know all the practicals from Unit 3 and from Unit 5, okay? I'm just going to go through them quickly, but remember, for each practical, remember you get marks for the procedure, what you're going to do, the measurements. Now, what you're going to measure and what you are going to use to measure things with. So if you're measuring the diameter of a wire, you'd use a micrometer, that sort of thing. Analysis. What you're going to do. Always think, is there a graph that I'm going to draw? If there is, what is it? So, the Unit 3 practicals, motion and collision of objects. You're probably going to be using some light gates somewhere along the lines to get some timing. Remember, if you're doing light gates, please make sure that you've said connecting them up to a data logger to a computer so that it can record that. Just the light gates won't give you a measurement. You need to know about the acceleration of free fall. There's the trapdoor and electromagnet method. Make sure you know that the problems with that method is that you might get the trapdoor sticking, you might have air resistance getting in the way, or measuring G just using light gates and timer. So for doing both of these, remember you're going to be using a Suvat equation. You are going to have time measured. You want to find acceleration. Your initial velocity will probably be 0, and you'll measure the distance. So measurements are going to be the ones that are ticked. You're going to be calculating A. So you're going to Suvat that and find the right Suvat equation to use. So S equals ut plus half at squared.Maybe you could do this over several distances and plot a graph of, well, what would the graph be? If we've got S equals ut plus a half at squared, ut would be 0. You'd probably plot a graph of different distances and different t squareds, and then your gradient would be a half a. Terminal velocity in fluids, that's the one where you drop it through the wallpaper, paste, the oil, whatever it is, and as it drops through every second, put a marker on the column, and when those markers are an equal distance apart, then you know that it's reached terminal velocity, and you can calculate terminal velocity just doing distance over time, because it's not accelerating when it's at terminal velocity. In all these practicals, make sure that you say you're going to repeat all of your readings, and if you can, don't just do it once, do several different readings and draw a graph like we said with this one. Okay, force extension characteristics for springs, rubber bands or polythene strips. We definitely did the one for springs in class. It's a straight line. Rubber bands was the one where you have the different loading and unloading, and the bit in between would be the energy. Polythene strips, very stiff at first, and then they extend absolutely heaps. Determining the Young's modulus. You guys have done that in class. We did a PAG on it. Make sure that you're measuring the diameter of the wire. Make sure you calculate the area of the wire correctly. Remember, finding the area of a wire, we're using pi r squared. Make sure you've got that r in meters already before you square it, or else it gets complicated. Okay, Unit 5. It's specific heat capacity and specific latent heat is the first set. So remember, that's supplying some heat using a heater. You find the power of the heater by doing I times V. You then find the energy supplied by the heater because you times that by the time that it's been on for. Okay, so have a look through those two. Make sure that you know them. Make sure you can say what you're going to measure and all of the different analysis for it. Okay, PV equals constant and P over T is constant. These are gas ones. I think we did PV is constant. Remember, to show that, you're showing that P is proportional to 1 over V, or V is proportional to 1 over P. So plot a graph of P and 1 over V, and you should get a straight line. P over T is constant. That should be, if you plot a graph of P and T, you get a straight line. So have a quick read through those if you can't remember doing those. Circular motion, I've talked about already, swinging a bung round, and make sure you're timing it for 10 revolutions, that sort of stuff. Remember, the bit that you get that's a problem with this experiment is the length of the string, because it's very difficult to keep that at a constant length. Okay, and the last one, determine period frequency of a simple harmonic oscillator. That's just, I suppose, timing it for a number of oscillations and then dividing your time by the number of oscillations to find the period. And remembering, if you want to find the frequency, if you know the period, frequency is 1 over period and period is 1 over frequency. Now, I think these are the only ones for this exam. I can't guarantee it's complete because I can't get onto some of my computer documents, but I just had a quick look through the specification and did a search for techniques and procedures, because that's what normally comes in front of the practicals, but I can't guarantee they're all here. Hope that helps. Send me an email or put a comment if you want me to go through anything else. See you tomorrow.